Okay, 8.7 is all about application problems. We're talking about exponential growth, exponential decay, interest rates. That's when it gets really interesting. Interesting. No pun intended. I love dealing with this stuff, like compound interest, that kind of thing. I love it. So here are the two formulas. You are not going to be given these, so you must memorize them. One is for exponential growth, one is for decay. You should be able to read a word problem and decide if it's growth or decay, because it'll say that it appreciates or it depreciates, depending on, or it increases or decreases. So we'll look at number one. It says a new jet ski costs $4,200. The value of the jet ski decreases by 10% each year. So would that be an exponential growth or decay? Decay. So A is going to be your initial amount, which is how much that it costs. So I'm going to say F of t equals 4,200 times 1 minus 10%. 10% as a decimal is 0.10 to the t. Now, I'm going to simplify this to be 4,200 times 0.9 to the t. It's the exponent. So t represents your time in years.
Oh, okay. So that's what you're solving for.
And then part B, it says determine when. So if it says determine when, that means I'm going to be solving for time. Like how many years is it going to take for my jet ski to be valued at $2,500? So what I want to do is plug in on the left-hand side. So my final answer would be 2,500, and I'm solving for t. So I'm going to say 2,500 equals 4,200 times 0.9, right here, part B, to the t. And this is what I want to solve for. So if I were to go about doing this, what do you think my first step would be? If I want to get t by itself, divide by 4,200. So the steps will be the same every time. So if you just memorize these steps, it's going to be like this every time. So I'm going to take 2,500 and I'm going to divide by 4,200 in my calculator. So you end up getting, oh, that's highlighter. You end up getting 0.595. Let's go out 3 decimal places. Equals 0.9 to the t. Now I have what I call an exponential. I want to put it into logarithmic form so that I can solve for t, because I want to get the t by itself. So how would I write this as a log function?
Log of 0.595 to the...
Let me write it like this. This might make it easier. If I write it as 0.9 to the t equals 0.595. If I write it as a log, it looks like what?
Log 0.9.
Log of 0.9 to the 0.595 equals t. So in my calculator, I am going to type in log. If you have an 84, then you remember you do alpha window 5. If you have an Inspire, which most of you do, you just hit the log button. Put my base as 0.9. For me, I want to keep it as exact as possible, so I'm going to go up and highlight the 0.595238 so that I can keep all of the decimals. Because I want to keep all of the decimals. So whenever I get to the number inside, you can either type in 0.595 or you can go up and highlight it. To get it more exact, if you go highlight your answer, you'll get a closer decimal. But I will obviously give you guys a little margin of error. So you end up getting t equals 4.924 years.
That's when you just plug it in the log.
You just hit the up button and select it and hit enter.
How do you select 84?
you hit alpha window 5 for an 84. 4.924. Okay, number 2. Let's look at number 2. I want you to try number 2. Write it exponential growth equation and then solve. So we're going to do the same steps as we did for part A and B, but instead of it being an exponential decay, it'll be an exponential growth. So 1 plus. Okay, so you start out at 1,219 monk parakeets. The parakeet population is growing 12% a year, so 1 plus 0.12. Then it's asking you how long is it going to take to get to 2,000. So my exponential growth equation would be this: f of t equals 1219, 1.12 to the t. Then I'm going to set the f of t equal to 2,000 and solve. So I divide by 1219 first, put it in logarithmic form. I always put my exponential on the left because it just makes more sense for me to, so I switched it around when I went from this step to this step. I don't know, it just makes more sense in my head if the exponential or exponent's on the left. Then switch it, put it in your calculator, you should get 4.369. Okay, try number 3. So once you get the equation, from there you divide 3,500 on each side, and then you get 0.87 to the t power equals 0.5. Then you switch it, the 0.87 goes down, the t and the 0.5 switch.
Why do they switch?
Just you're switching it from exponential to logarithmic form.
Oh yeah, because I had like 0.87, but I had 0.5 and 0.87 like.
Switched.
Yeah.
So when you're changing from exponential, the number that's next to the t always goes down to the base. And then these two switch. So the number on the right is the big number. The 0.87 that's next to the t goes down to be the base. And that's the case every single time.
So whatever.
Okay, now we're going to look at what we call compound interest. So you may see something where it says it's compounded monthly, quarterly, daily. It's not just it accrues interest or depreciates every year. So the formulas are just a little different.
Do we have to memorize these?
Yes, in that you now have this variable that we call n. N just represents the number of times it's compounded per year. So if you say quarterly, then n equals 4. If you say monthly, n equals 12. If you said daily, then it would be n equals 365. And then the continuous, meaning like it's continuously compounding interest, is the formula PERT.
Huh?
PERT. P times E to the RT. PERT. Really easy to remember. So that's where the E comes in. That's why we use E's. And anytime people ask, when does LN or E ever come in handy? If you have any financial job, or you ever want to, or if you're ever interested in investing money or savings account where it's being compounded.
Upper school, pardon the interruption. Okay, before